Hi, and welcome to this lesson. In this lesson, we're going to go over and talk about common network hardware. This is hardware that you would see as a technician on site when you are in your professional role, whether that be an enterprise role, working for a small business, or wherever you may be. These are the common network hardware and devices that you will come across in your role as an A plus certified technician. In enterprises and small businesses, one of the most important features or characteristics that you'll find in a business or an environment like that is the cabling infrastructure, network cabling that connects the computers to the network devices. And again, depending on your setting and your environment that you're in, you will probably see a lot of desk out on the floor of the office and a lot of desk and computers connected by Ethernet cabling. Whether it's on the floor or in offices, they'll be connected to Ethernet cabling, and this cabling will run either under the floor or up the wall, or it'll go back to a central location to the wiring closet. And the wiring closet is the centralized location where a lot of your hardware networking devices are connected. So if you were to follow this cabling, you would go into the equipment room or the wiring closet. And in this wiring closet, you would see a patch panel. On one side of the patch panel, you would see something like a 110 block where Ethernet cables are punched down or terminated on the 110 side, and they will be color coded. On the other side, you would see RJ45 connections from patch panels to network equipment, most likely switches and other devices. So, again, starting from the desk and the laptop and the cabling out on the office floor or in that environment to the wiring closet to the patch panels, this is what you'll come across and what you'll see. So let's talk about the patch panel in a little bit more detail. So network cables are managed at the patch panel, and this gives us a very centralized and easy way to manage network cablings coming into the wiring closet from the computers and the network locations out on the floor. Connections are patched or punched down onto the 110 panel on one side, and they're plugged in on the RJ45 side, going to a network device. If you'll see on the images below, you'll see on one side of the patch panel is RJ45 connections. Some patch panels have RJ45 connections instead of the 110 patch panel. On the next image, you'll see the common traditional 110 punch down panel. And on the next image, you'll see the RJ45s as they connect and leave out and go to the network devices, whether that be switches, routers, firewalls, and so forth. It's important that you're labeling on the jack on the floor and the jack where it comes in at on the patch panel matches. This would be easy administration. If somebody needs to move physically, they can move locations. And in the wiring closet, that coordinating jack can be unplugged from one switch and moved to the others. It's very important that your labeling matches on both sides. One of the things that you'll see on small business and some enterprise locations is the type of internet connection they may have. They may have internet connections from different providers. If they have a cable internet provider, you'll see what's called a cable modem. Now, the cable modem or the DOCSIS, data over cable service interface specification, is a device that's put in normally by the provider, and it comes in through a coaxial cable. It provides broadband internet at multiple different frequencies. A lot of times, these ISPs or these cable ISPs, they can provide multiple services over that coaxial cable. It could be data, it could be voice and video. And so it's a high-speed internet connection, and speeds range from anywhere from 4 megabits up to 250 megabits. Gigabit speeds are available. Another type of internet connection that you'll see in small businesses would be a DSL modem. DSL, or the proper name is asymmetrical digital subscriber line, is a competitor to cable. So this is another type of internet connection, but it's actually being brought in on a phone line. So you'll see a phone line coming from a terminal plugged into a device like the image right here. Now, asymmetrical DSL, basically what that means is one speed is faster than the other. And normally it's the download speed is faster than the upload. Now, DSL has a distance limitation from the central office. Normally it could be anywhere between 8,000 and 10,000 feet, feet from the central office location. So its availability is limited. Also, its speeds may be limited as well. Speeds may be up to 52 megabits download and a 16 megabit upload. But again, that's going to vary from location and also location and proximity from where you are from the central office. So the next device in the network infrastructure where you'll see in a wiring closet or equipment room will be the router. The router is an important device because basically what a router does is it connects networks. It routes IP traffic between networks. It makes the forwarding decisions between based IP addresses. So it's based on if an IP address is allowed on certain network, it'll allow that connection. Routers are typically they route from the internet to a LAN or from a LAN to LAN. So again, internet may come into a router and it routes it to the local area network, or some enterprises and device and offices and companies may have a router for specific departments and it will route from one router to another router to a different department. And generally, these are modular. They'll have different connections for LAN, WAN, copper, fiber, and wireless. So the next in line would be a firewall. And now a firewall works on the principle of a router, but it's a little bit more robust, does a lot more things. So basically, a firewall protects the network by filtering ports and applications. Generally, a firewall will operate on the OSI layer 4. It's sometimes called as a layer 4 device. However, there are different firewalls that operate on higher levels, such as layer 7. These are applications, so they make decisions based on applications. So it's a layer 7 device. A firewall can do many things. It can proxy traffic, different capabilities. It can provide routing. It can provide DHCP, dynamic host control protocol. Also, it can encrypt traffic. And a lot of times, your firewall can do site to site or remote VPNs as well. One of the backbone components of your network would be a network switch. The switches actually make the connections throughout the LAN environment and sometimes WAN environment. So it's like hardware bridging, and the switching decisions and the routing decisions are made in what's called the ASIC, the application specific integrated circuit, and that's where all of the forwarding decisions are made. Now, network switches are very robust. They forward traffic based on MAC address. So there's a MAC address table that it holds, and it remembers and knows that if a signal is coming from one MAC address and it's being targeted to another, it knows what port that device is in, that MAC address, and it sends it to that port. Um, they may provide power over Ethernet. We'll talk about those a little bit later. And again, these are the core of the network. They're the backbone of the network. Normally, switches operate on layer 2, but however, some switches may have routing capabilities. And if it does, it may be considered a layer 3 device. It may be called a layer 3 switch. A little bit more deep dive on switches. There's two different types of switches. You can have a managed and an unmanaged switch. An unmanaged switch is basically for lower volume use, smaller applications. You may have a desktop and a printer and another network device, like an IP phone or some sort. It may not need a robust switch like a managed switch. Um, the unmanaged switch is no interface. You can't go in and manage it. It does not do any special um, uh, switching like VLANs or anything like that. It's just a basic connectivity device. Now, your managed switches, they are more higher volume, and they also have a management interface, whether that be a web interface or whether that be an SSH. It provides VLAN support, traffic prioritization, spanning tree protocol. So, of course, these may come at a higher price point, but they do a lot more things. Again, these are your core type switches that will be in your enterprise and your higher end networks. Now, a hub or what is called a network repeater, they're generally not used nowadays. These were actually the prelude to switches. Now, hubs don't make decisions. They basically get information from one port and regenerate that or repeat that out of all the ports. It's simple logic: receive, regenerate, resend. And again, that's it. And basically, that's what a hub does. It resends all the information out of all the ports. It only worked at half duplex speeds, and the 10100 was the high speed and throughput that it was capable of. So, as you can see, these are not robust and are not really found, but they're still out there. So, you may come across a hub. Access points. Access points are the wired devices that gives us wireless capabilities. So basically, it extends the wired network to wireless devices and allow those wireless devices to connect to our wired networks. It forwards device configuration information to the client. So I have a laptop and I'm connecting to the access point. It's going to give me an IP address from the firewall or whatever's providing the DHCP IP address. It's going to tell me what my gateway is, and it's also going to provide me DNS. Now, this access point, it doesn't make all these decisions on its own. It's based on how I'm connecting. If it senses that I'm a wireless device, it will pass all that information through from whatever on the network is providing that. So it's a type of bridge, more or less. Now, one thing about access points, they can be managed individually right there on the spot, or what they could be is managed through a configuration or controller, or and managed as a group. They can be managed individually or managed as a group of devices, sending out configurations to all of them. Power over Ethernet. Power over Ethernet is a standard that has come across several years back, and it has saved installers and enterprises lots of money and also lots of time as well. So basically, power over Ethernet is power supplied over Ethernet cable. Supplies connectivity and power over that single Ethernet cable. Again, saves on power installation costs and on additional cabling. The power provided by the network device, it can be either in the switch built in, which we call an in span, or it can be an inline, like a power injector, which is called a mid span. So if you look at a PoE switch, generally you'll see that the PoE ports are marked, which ports are PoE and which ports are normal ports. Also, the injector has two ports on it. One is for the PoE. That's the port that sends out the power, and the other port is LAN, and that sends out the connection to from that power injector back to the switch. Now, there's different standards of PoE. First, we have the PoE, which was the original standard. That's the 802.3AF, 15.4 watts of DC power, 350 milliamps max current. And again, that was the original specification. Next came out was the PoE Plus, and that was 25.5 watts of DC power, 600 milliamps of max current. And now we have the newest standard, which is the PoE Plus Plus, and this is 802.3BT. There's two types, Type 3 and Type 4. Type 3 is 51 watts, whereas Type 4 is 71.3 watts. ONT, the Optical Network Terminal. In recent years, you probably heard the term fiber to the home or fiber to the business. This is the box that delivers that fiber connection to your home or to your business. The fiber connection comes from the provider to this box, and from that box, you have a network connection from that box to your home. So this is the provided by the ISP or the provider and connected and demarked to your location. Sometimes these units have a backup battery in case of power failure. Network interface card. The network interface card is the one of the most common devices that you'll see in a business environment or even in a home environment. This is common to desktop, laptops, printers, and also industrial devices, projectors, phones. This is the network interface card that receives the internet or the Ethernet connection. And as you can see from the image here, is generally plugged into a motherboard where it's an add-on, or sometimes it's built right on the motherboard and it's basically on board. They come in different speeds, the 10100, 101,000, and gigabit. Software defined networking. In recent years, software defined networking has come available and has exploded into networking and management. With the onset of virtual computers and virtual infrastructures, software defined networking has taken traditional management of devices and made it virtual and put it to the cloud, extended that capability to the cloud. So if you look at software defined networking like this, traditional networks have really limitations. And so that's why software defined or SDN came about. Network devices have three really logical operations: data, control, and management. So I'm going to explain those a little bit more. So the XDN extended those capabilities or functionalities to the cloud. So SDN was built for the cloud. You can manage it from a single distributed location, and of course, it's very scalable. So again, three logical operations for network devices. So if we look at it this way, in a network device, whether that be a switch, a firewall, a router, there is a management, and there is the control, and there is the data. So on the management side, that's where you connect to manage it. That's where you do your management configurations and so forth. The control layer or the control plane, what is known in SDN, is basically all the routing decisions. In a firewall, it would be your routing tables, or in a switch, it would be your MAC address table. All that functionality has been extended to the cloud. And at the infrastructure layer or the data plane layer, this is normally in a switch. These are your ports that goes out to your networking devices. Um, in the SDN, this has been moved to the data plane, and this is what tells the in networking devices what to do based on the control plane. So whatever configuration, whether it's routing and switching or whatever, it's done through the data plane. So that's SDN. That's how our basic three logical operations or functions in network devices have been extended to the cloud. Okay, in summary, for this lesson, this is all the information that we covered of common hardworking networking devices. We covered the patch panel, the cable modems, DSL modems, routers, firewalls, network switches. We talked about the hub, which is really a repeater, power over Ethernet, the ONT network interface, and we finished off talking about software defined networking. I'm glad you were here with me on this lesson. Thank you very much, and I will see you in the next lesson.